Yeah.
Oh, she's your student now.
Oke, sudah bisa kita mulai.
Oke, kita mulai. Are you ready, Professor? We will
Yes,
start shortly.
if you could please set so that I could share my screen. Yeah.
Yep. Or we will waiting another minutes for participant to join with us because it's still 31 participant include us for both of us, four of us.
Sure. Yeah, because when I click on the share screen, am I allowed to share my screen, by the way, Kiki?
We made you co-host, so I think you can share your.
Maybe yeah. Let me just try. Yeah. Okay. So it looks like yes.
You can try to make it visible. Okay, it's okay, clear.
Excellent.
Excellent.
I'll put it here so that you can see my face nicely, and I put it to presentation mode. And yeah, can you see my proper screen instead of the presentation mode?
Yes, I can eat properly.
Okay, excellent.
Yeah. Looks okay from my end as well. Looks okay.
In which case, I'll set it properly as well. I'll put a laser pointer. Yeah. Okay, good.
Because the time is still less than 3 p.m. in Indonesia, maybe we will waiting another minute or.
Yep, sure.
Another minute.
Wait a second. Stop sharing. Yeah, something has gone wrong. Yeah, that's why I should share.
Good. This is your university? Great.
Yeah.
I think you need to make a full screen, Tong.
It is full screen.
Hold on.
No.
Are you seeing my presenter mode or the? But no, you should be seeing my full screen.
Full screen, but in minimize.
Minimize?
Yeah. Because in another slide, in another part, there is the next slide.
Oh, that's a presenter mode. Interesting. Yeah. No, that's okay. I'll just end presenter mode.
Okay.
Can you see my?
Okay.
Yes, is it? Are you seeing?
This is Maximus size.
Resume slideshow. It's funny. Sorry. That's interesting.
Okay, somehow it's not responding.
Can you see my screen, Tina?
I can, yeah, but it's not the full screen presentation. I think you need to make it.
It's funny, you know.
At the top of.
It's not a slideshow.
Top of the bar.
Look, I think I'll just unplug it. I think this is making it complicated. Just bear with me. Can you hear me?
Yes, now it's okay. Now it's
perfect. I think you get confused because I have two screens. Yeah.
Yeah, there are two screens.
Now you should see my.
Up.
Yeah. But yeah. So it's okay. Yeah, but so be it. No. But this is just a little bit just a bit funny. Okay. Yeah, I suppose you can see my laser pointer now.
Okay.
Yes.
Oh, sip.
Yes, we can.
Okay, good. All right. Good. Okay. Takes a while. Yeah. Okay. Oh yeah, it's not. Of course, my mouse is not working. Okay.
Should we start now, Miss Kiki?
If anyone is ready, we will start. But the participant is still less than 100. Okay. The committee said we can start. Are you ready, Professor?
Yes, I am. Yeah. So yeah. Okay. So thank you very much, my fellow Indonesian academics, for kindly inviting me to deliver this lecture on what we have done over a long period of time to compare the ground source heat pump versus air source heat pump performance. But before that, on behalf of the University of Western Australia, I want to
Professor, maybe
Yep.
we will opening ceremony first
Okay.
for official opening this event, and then we will ask you to present your article.
Okay. Yeah.
Okay for you, Professor?
Absolutely. Yeah.
Okay, may I have your attention, please, the audiences? We will start our symposium now, and please mute your microphone to avoid the interruption during the presentation. Okay, good afternoon. Assalamualaikum warahmatullahi wabarakatuh. Your Excellencies, Rector of Universitas Negeri Padang, Dean of Faculty of Engineering, Head of Department of Mechanical Engineering, and also Head of Research Institute and Community Service, Editor-in-Chief, Professor Shahril, now with us here, and the Honorable Speaker, Professor Tong Chua. Ladies and gentlemen, it is my happiness to be an MC and a moderator for the second symposium organized by Teknomekanik Journal, Department of Mechanical Engineering, Faculty of Engineering, Universitas Negeri Padang. I am Sri Rizky Putri Primandari, but you can call me Kiki. On behalf of Teknomekanik Journal and the committees, I would like to welcome you all to this symposium. We appreciate you to join us in the middle of your busy schedule. We hope you enjoy this symposium. To opening this symposium, we are pleased to have Professor Shahril, Editor-in-Chief of Teknomekanik Journal, to deliver the opening speech. Professor Shahril, please, time is yours.
Okay, thank you, Kiki. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon.
Waalaikumsalam.
The Honorable for Rector of Universitas Negeri Padang, Prof. Benepri, PhD. Honorable to Dean Faculty Engineering, Mr. Fahmi Rizal, the Honorable the Head of Mechanical and Mechanical Engineering Department, Mr. Purantono, with all lecture and staff committee. The special one, our speaker, Mr. Professor Tong Chua from the University of Western Australia. Thank you for your sharing, your knowledge, and all respectable attendant. Ladies and gentlemen, first of all, let us thank to Allah who has given us His blessing to that today. We can see a host virtually here to join this event. My heart appreciation to the committee who have worked hard to the whole is this symposium. This event is a Peace International Symposium, which is presented by Teknomekanik Journal, organized by Department of Mechanical Engineering, Faculty of Engineering, Universitas Negeri Padang. For your information, it is international journal which is dedicated to the improvement and dissemination of knowledge on the methods, policies, technologies in technical science and vocational education. It's welcome contribution from all who wish to report on new development and latest finding in engineering and education. New trend and progress provide practice in less field, thus creating a unique forum for interdisciplinary or multi-discipline knowledge. Teknomekanik Journal published 2 issues a year, and it has been indexed by Sintafo, Google Scholar, Garuda, and Dimension. So, for everyone who has qualified article with these areas, please send to Teknomekanik Journal for publication. Ladies and gentlemen, this symposium, we will have an outstanding speaker from University of Western Australia, Prof. Tong Chua, with his paper titled Ground Heat Pump and Air Source Heat Pump Performance Comparison for Domestic Application, a case study in Perth, Australia. This paper contains updated knowledge, so we can get new input and understanding from it. Everyone, please follow this symposium well and take a good advantage of the question and answer session. Last, I'm as editor-in-chief of Teknomekanik Journal. Once more, would like to welcome you all this international symposium and wish this event will be benefit to everybody. Now, I officially open this symposium by saying Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, sir, for the opening the symposium officially. Now, ladies and gentlemen, the main session of this symposium is a presentation from our invited speaker, Professor Tong Chua. But keep your question until we are in a Q&A session. The audience could give the question through the chat column during the presentation by stating your name and your affiliation. However, before the presentation, let me introduce to you our speaker, Professor Dr. Tong Chua. Professor Chua holds a PhD, Master of Engineering, and Bachelor Engineering in the first class honors in Mechanical Engineering from the National University of Singapore, NUS, Currently, Professor Dr. Tong Chua is a professor of chemical engineering and head of Department of Chemical Engineering at the University of Western Australia, Perth. Prior to joining University of Western Australia, he has an assistant professor at the Faculty of Engineering of the National University of Singapore. His research interest covers heat and mass transfers, thermodynamics, process engineering, and waste heat utilization. He has published 106 articles. Wow. Indexed in Scopus with Scopus Index of 31 and Google Scholar Index of 37. Incredible, Professor. From 2008 until 2012, Professor Chua was the above ground engineering program leader of the Western Australian Geothermal Center of Excellence. Ever since then, he has been focusing on baseload geothermal energy. He collaborated with Development Western Australia on the Full Earth project, which compared the performance of the ground source heat pump with an air source heat pump, and was the joint winner of 2019 IRA HVAC and R Research Excellence Award. He also collaborated with the BT Park Laser Center on measuring the heating capacity of geothermal outdoor Olympic-sized swimming pools and comparing them with the various model prediction. Since 2020, he is the non-executive director of Groundwater Energy Ltd, focusing on delivering green hydrogen for baseload geothermal energy. Please welcome our speaker, Professor Chua, to present his topic on ground source heat pump and air source heat pump performance comparison for domestic application, a case study in Perth, Australia. Please, Professor, time is yours. Enjoy your time.
Thank you very much for your very kind words, Kiki, and for the warm introduction, Professor Sharil. Yeah, I'm very much humbled by your hospitality. To start off, on behalf of the University of Western Australia, I want to acknowledge that this lecture on my end is conducted on the Whadjuk Noongar land, and that the Whadjuk Noongar people remain the traditional owners of this land, and that the Whadjuk Noongar people remains as the cultural and spiritual custodians of this land and continue to practice their values, languages, beliefs, and knowledge. I pay my respect to the elders, past, present, and emerging. So let me just start off by briefly introducing my university. So the University of Western Australia is one of the group of 8 university or sandstone universities in Australia, and are classified as research intensive institutions. So this is our main campus that you are seeing on this slide, and here you can see a wider vista of the landscape of UWA, and I hope you can see my cursor there. And over to the left is the sparkling Matilda Bay. So we are next to the Swan River here. And in the evening, we have very good environmental regulations here. So in the evening, most evening, we will be visited by wild dolphins here, and black swans, and cormorant, and other wild birds here. Okay, so it's a very beautiful campus. This is our clock tower here, and in our engineering precinct, we have the latest E-Zone award-winning building here, which we are very proud. And this is meant for student activities and allow students to do their learning and activities here in ease and comfort. All right. So, and we will conduct our teachings here as well. So in terms of its achievements, the university is widely recognized for both its science and engineering achievements. we are very proud to have 2 Nobel laureates in medicine and physiology in discovering the Helicobacter pylori and its treatment, which benefits the entire Asia Pacific region. Yeah, even my mom is benefited from the discovery of the 2 Nobel laureates and rid herself of the long-term gastro problems. And we are also have nurtured a few medalists in mathematics, and one was key in terms of the discovery of gravitational wave, which is of course received a Nobel Prize for the LIGO recently. In engineering, as a head of department, what my motto is that we are engineers training future engineers, and we engage very actively with the industry. And apart from academic research, we also are very active in the spinning off of companies. And for example, I've successfully helped the university spin off a company and got it public listed in 2015. Currently, it enjoys a market capital of about $130 million Aussie dollars, and is listed on the Australian Stock Exchange, for example. So this is our kind of a sample of the whole of campus activities at the University of Western Australia. So let me come to the crux of today's lecture. So I would like to share with you the long-term performance comparison of ground source heat pump against the performance of air source heat pump for domestic application. And this study obviously focused in the climatic region that's contextual to the Perth metropolitan area of Western Australia. I'm absolutely delighted to be accompanied and to interact with a very talented student, and one of whom very talented student is Tina Aprianti, who is undergoing PhD study with me, and she hails from the Sriwijaya University of Indonesia. It's a great pleasure to train a very talented lady from Indonesia. And I have also, as part of my co-author, a young Professor Srinivasan Kandadai, who in his earlier year was a professor at the Indian Institute of Science, and he's my long-term friend. So this project is a long-term collaboration between multiple stakeholders, the prime of which is our state government arm, the development WA. So WA here stands for Western Australia. So this is the arm of our state government in managing our land and sometimes helping to lease out properties that's owned by the government. The ground source heat pump is donated by GeoExchange, the equipment supplier. Alcock Brown Neef Group, the builder, is responsible for the construction and delivery of the 2 properties that is studied in this research. And the neighborhood area that is kind of like, if you like, within which the property resides is Vive at Craigie. And this is Carbonomics, the independent consultant that assists us in installing the sensors and the cloud data collection system. So the backdrop here is a graphic rendition of the property fitted with the ground source heat pump. And I would like to draw your attention in this graphic to the long PVC polyvinyl chloride pipe that leads deep underground to a depth of 57 meters, which I'll allude to in greater detail later. And this is the piping and the control system for the submersible pump, which then leads the groundwater into the ground source heat pump, which resides within the property. This study is award-winning and was a joint winner of the 2019 Research Excellence Award by the Australian Institute of Refrigeration, Air Conditioning and Heating in the area of heating, ventilating, air conditioning, and refrigeration research. And the award was given in recognition of the significant knowledge that this study has contributed to the industry. All right. This is the smiling team that helps deliver this long-term project. The project started off from an MOU among multiple stakeholders in July 2014. So that is a long time, yeah, leading to here is a 7-year project. So in the background is the property that is fitted with the ground source heat pump. And this is John Clifton from Development WA, and under whom is Silver Chan, Chanel, and Greg Ryan, all of whom hails from Development WA. So this is Michael DeMayo, formerly from GeoExchange, which supplied and kindly donated the ground source heat pump to this study. This is Peter Buck, the driller, who collaborated with GeoExchange and with Carbonomics. And this is Max Plumis, the independent consultants of Carbonomics here. This is Brandon Evil from the ABM group, which developed and delivered this property and the property that houses the air source heat pump. So this is the street view of the two properties under study. So the property to the right is the property that is fitted with the ground source heat pump, and the property to the left is fitted with the conventional reverse cycle air source heat pump. So significantly, the property here is also supplied with borehole irrigation, namely the groundwater that is extracted from underground. There's I think we are allowed by the Perth regulation that the irrigation can happen for 3 days a week. So the extracted groundwater for 3 days a week can be used for subsurface irrigation of the lawn here that you can see here. And borehole irrigation in Perth is a very common practice. So over the extent of Perth metropolitan area, by the latest census, we have about 190,000 borehole irrigation installed. Yeah. So which is why when ground source heat pump is applied in tandem with borehole irrigation, it makes for quite a compelling proposition for Perth metropolitan area, as I'll explain more, yeah, later. So this is a graphic rendition of the same two houses. These two houses are built on a block of about 375 square meters thereabout, and the living area is about 200 plus square meters. And these two properties are built to the same specs, and they being located next to one another also are subject to the same outdoor condition, which is quite important for the baseline comparison. The property to the right is fitted with the ground source heat pump, and you can see the PVC pipe that leads deep underground here. And here, the property to the left, and at this wall here, you can discern the outdoor unit of the split air conditioning system. So in a nutshell, the whole notion of ground source heat pump, its proposition lies in the premise that, you know, on a hot day when cooling is required, the machine, the air conditioning system, is cooled by the cool underground water as opposed to the hot ambient air. Conversely, during winter, when the machine delivers heat to the indoor environment, the ground source heat pump draws upon the warm groundwater and supply the heat to the indoor environment as opposed to drawing heat from the cold outdoor air and strive to supply the same heat to the indoor environment, so that in principle it should enjoy an efficiency premium compared with the reverse cycle air conditioning system. And our task is to quantify this hypothesis and to inform the state government the extent to which this premise holds. This is a floor plan layout of the two properties side by side. You can see here to the right is the one fitted with the ground source heat pump, and to the left with the split air conditioning system. So we have here a double lock-up garage. They are all built to the same floor plan, so they are architecturally identical. The air conditioning system is ducted, which is a very common practice here in Perth. And there are 6 zones. It's an all-air system, 6 zones to the air conditioning. This is the master bedroom here. This is the cinema room, and these are the 3 bedrooms here. Yes, and finally, this is a living dining area. The ground source heat pump is located here at the corner of the garage. Conversely, in this property, the outdoor unit can be seen here of the split air conditioning system, and then the indoor direct expansion unit is located up in the attic. And this is a Samsung unit, which is a very common and widely very popular model in Perth. So this is the interior of the property fitted with the ground source heat pump. This is, I believe, the master bedroom. And this is the living area. Obviously, this is done. These photographs are taken during a period whereby it's on open display. Because this research is subject to the human research ethics oversights of the University of Western Australia. So this is during the open display period, whereby prospective buyers come and visit the 2 properties. So it's very important for me to mention and to acknowledge that apart from the multiple stakeholders that contribute to this project, we are very much indebted and grateful to members of public who kindly avail this property to the study, because these properties are owned by members of the public and bought in the open market. I think on the order of 600,000 per property. These properties have enjoyed high Energy Star rating, are fitted with solar panels and solar hot water, among other things as well. And in terms of the occupants profile, it is 2 adults and 1 child in terms of the profile of the occupants within the 2 properties. This is the heart of the technology of ground source heat pump. And you can see here to the left is the doublet system, whereby instead of conventional 2 borehole system for geothermal low enthalpy air conditioning system, we have here instead just 1 borehole. The submersible pump is located here. Now, because at the Viva Craigie, this neighborhood area is located at a fairly elevated site, which is atypical, the water table is pretty low, sited at 57 meters from the surface, which is why this doublet system, the pipe-in-pipe system, has to be sunk to a, sorry, I beg your pardon, the water table is 35 meters, and so that the borehole has been drilled to a depth of 57 meters. The submersible pump is located at the bottom, and then it is the groundwater, cool groundwater is extracted at depth, is pumped to the surface, run through the plumbing system, and once used, is returned via the collar down to just under the water table, okay? And then the spent groundwater will then diffuse slowly toward the coastal area. The valve is located near the coast for the audience information. The diameter of the drill hole is 200 millimeter, and material here is, as I mentioned before, is PVC. And these are the screens here, whereby it returns the spent water underground, and this is the screen here to extract the cool ground water. And this is where the submersible pump resides. This is a greenfield project because the neighborhood is a new development project. So Peter Buck, the driller, will deploy the drill rig to the site, and the drilling lasted for 14 days. During the drilling period, the drilling process actually experienced a huge underground cavern, and so resulted in a fairly significant mud loss. But after that, that was arrested, and the project picked up again, which is why the drilling took a fairly long while, 14 days to complete. Yeah. This is the Groundswell seed pump, which, as I alluded to earlier, resides at the corner of the double lockup garage. This ducting here returns the room air to the Groundswell seed pump, and after the air conditioning treatment here, the conditioned air is sent via this duct back into the indoor environment. So these two pipes here supplies and return the groundwater. The pipe closer to the door leading down supplies the groundwater to the heat exchanger of the ground source heat pump, and then the spent groundwater returns via this pipe back underground. So the heat exchanger therein that processes this groundwater is a coaxial tube heat exchanger, which, because of its volume, does require a slightly higher refrigerant charge than the split air conditioning system. But I think the manufacturers strive to optimize for performance to achieve a full counter current flow, which is why they opted for the coaxial tube heat exchanger to undergo heat exchange with the groundwater. The refrigerant used here is R410A, the same as in the split air conditioning system. So this is the motor and the control module for the submersible pump, and the motor rating is 900 watts. So in terms of energy audit, the power consumed by the pumping, the submersible pump, is included into our energy audit to arrive at the coefficient of performance of the ground source heat pump, which I shall report later. So this is the ducting layout of the a perspective view of the ducting layout in and surrounding the ground source heat pump here. You can see that the plumbing system runs through the attic. Okay, the green pipe here supplies groundwater to the ground source heat pump, whereas the brown pipe returns the groundwater back underground, once again routing along the attic, which then leads out of the property and goes back to the backyard where the doublet system resides. A major, as I mentioned, this is a long-term study, and most of the time spent was in commissioning and calibrating the system, because we have extensive instrumentation of the ducted air conditioning system in the two houses. And in terms of the bottleneck of the sensors error, the bulk of which resides in our ability to measure the airflow rate. That is the bulk of the error as in our measurement. So this in this picture here, we have undergone an extensive exercise to use a test hood here to and in tandem with the omnidirectional hot air anemometer to calibrate the velocity as picked up by the hot air anemometer and measure against, correlate against the airflow rate from each of the diffusers, yeah, in the various zones of the within the property. So these are my students, engineering research project students who underwent training under this project. So, and this is the setup of the omnidirectional hot air anemometer up in the attic. Yeah. So this chart is quite crucial to the whole study because it correlates the velocity as measured with the omnidirectional hot air anemometer against the measured volumetric flow rate for both the ground source heat pump, which is the data is in blue, and the air source heat pump, the data is in brown triangle, solid brown filled triangles here. So you can see here that the error bar experienced quite a bit of turbulence in terms of the velocity because of the constraint of the attic size. We cannot have sufficient length to straighten out the flow. So we have to actually grapple with the turbulence of the air and correlate against the volumetric flow as picked up by the test hood at every diffusers. But so this was the tensest moment in the project, whereby this is really the most crucial part of ascertaining and getting high quality data. But suffice to say, we are very proud to report that the volumetric flow rate that actually we measured at every speed setting of the system was spot on compared with the manufacturer's catalog data to the third significant figure. So I'm professionally very proud of that achievement. And to the extent that I can actually point to the manufacturer, which is Bosch, a water furnace, actually water furnace, with that GeoExchange has an agency of. I could point to water furnace that it actually reported wrongly of the airflow rate at the lower speed setting. Yeah. So that was my most gratifying moment, that we know that we have got this right, okay, which is the most crucial point for the project. So the data collection started sometime in 2017. Mind you, the project actually started in July 2014. Yeah, and then and we have 3 years of preparation and commissioning and troubleshooting and so on. But finally, in 2017, we could finally commence data collection. So the ordinate here. So this is if I can check I believe this is the cooling, because that's it. Yeah, this is the heating psychrometric plot of the fan coil unit. FCU stands for fan coil unit. So the outlet condition of the fan coil unit versus the inlet condition to the fan coil unit for the two heat pumps, namely the ground source heat pump and the air source heat pump, in the two different properties. You can see here that in terms of heating application, the air source heat pump, well, you can see here, this is the indoor environment, and you can see here they are almost, for all practical purposes, quite nearly the same for the two properties in terms of the inlet condition to the fan coil unit. But interestingly, in order to sustain heating for the Samsung unit, the the fan coil unit outlet temperature is significantly higher than that of the ground source heat pump, which signifies that, you know, the ground source heat pump actually delivers a higher airflow rate for the same kind of enthalpy difference than the air source heat pump, which also points to likely that the heat transfer coefficient for the ground source heat pump and the fan coil is higher than that of the air source heat pump. In terms of the data collection protocol, every data here undergoes at least 45 minutes of steady state operation before we admit the data. And we sift through and filter out data in terms of the fluctuation in the dry bulb temperature, as well as the humidity ratio as well. So, which is why you can see that the data, the steady state data that I'm presenting here, bunches up very, very nicely, and there's very little scattering. Yeah. So this is the cooling psychrometric plot of the fan coil unit outlet condition versus the fan coil unit inlet condition. So again, over here, we have the ground source heat pump, which is the data in black, and the air source heat pump, the data in brown. You can see here that the householder in the property fitted with the air source heat pump prefers a warmer temperature, but very interestingly, the fan coil unit outlet condition for the air source heat pump is a lot colder than the ground source heat pump here. Okay, so in other words, again, the situation is similar to the heating condition, whereby the enthalpy difference is smaller in the ground source heat pump as compared with the air source heat pump, pointing to a higher fan flow rate, which again suggests that the heat transfer coefficient is better for the ground source heat pump versus that of the air source heat pump. And this is correlated well against the air velocity measurement at the fan coil units. For the heating condition, you can see that the airflow rate, which is correlated against the higher velocity of the ground source heat pump, is certainly significantly high, more than that of the air source heat pump. So this is for the heating condition, and the same applies to the cooling conditions consistently, that is registering a higher airflow rate. So I want to now come to the heating and cooling capacities. Obviously, because of human research ethics oversight, we have no control whatsoever over the behavior of the occupants of the two properties, and we really shouldn't exert any control. And so, but they kind of quite gratifyingly kind of self-assemble and toward a fairly consistent kind of indoor condition, which is very gratifying. But in terms of the absolute heating and cooling capacities of the two properties, certainly the ground source heat pump is consuming a greater capacity here, yeah, for both heating and cooling, all right, compared with the corresponding air source heat pump capacities. So very importantly, these data are collected over 2 years. So it spans across 2 summers and certainly 2 winters in this case. So because of the disparate absolute capacities, both in cooling and heating, we analyze the data based on the coefficient of performance of the air conditioning unit. So simply put, the coefficient of performance here means the efficiency of the system, and it is a ratio of the heating or cooling capacities derived by the machine divided by the electrical power input into the machine. Importantly, in terms of the COP auditing, the ground source heat pumps actively considers the power consumed by the submersible pump, which consumes 900 watts. So all this has been taken into account, and certainly the fan power as well. So you can see here that in the heating mode, the ground source heat pump, the COP of which is fairly insular against the difference or variation in terms of the ambient temperatures here. Of course, you can still see a spread which is due to human activities and human preferences within the household. But average-wise, the COP measures 3.9. You can see the error spread per data point here. This is the corresponding heating COP of the air source heat pump at the comparable range of temperatures outdoor, I stress. Importantly, one can discern here the dependence of the air source heat pump COP against the outdoor air temperature. Namely, the colder the ambient condition, the lower the efficiency of air source heat pump. Whereas for ground source heat pump, it remains, for all practical purposes, constant, okay, and average at 3.9. So overall, in terms of the efficiency gain of ground source heat pump versus that of air source heat pump, it can be as high as 60% better than that of the air source heat pump in heating mode. Now let us turn our attention to the cooling performance, yeah, of the two machines. So this hollow circle here shows the COP of the ground source heat pump over the summer with temperature ranging from 25 through to sometimes as high as 40 degrees Celsius. And once again, we can see that it's pretty insensitive to the outdoor air temperature, and the COP of which averages at 3.1. Conversely, for the air source heat pump, the COP of which display significant dependence with the outdoor air temperatures. Once again, the hotter the outdoor air temperature, the lower the coefficient of performance of the air source heat pump. And depending on conditions, and certainly in the outdoor air condition, but the COP of the ground source heat pump can be 100% higher than that of the COP of air source heat pump, okay, which is pretty significant. Now, this is a very important graph tracking the temporal variation of the bore water temperature over time. You can see the monitoring started in September 2017 and ended in September 2019 over a span of 2 years here. So you can see we have this is a summer period. There are 2 summer periods and we have 2 winter periods. So this is the extracted groundwater temperature, yeah, during the summer period, and there's a brief winter period here as well. So you can see that they are holding pretty constant in terms of the baseline groundwater temperature. So this is the returning groundwater temperature after cooling application. So now come to the winter season. The groundwater holds once again pretty constant yet again, and this is the spent groundwater temperature having had his energy extracted by the heat pump. This is then returned underground. So you can see over time, over the span of 2 years, the groundwater temperature remained practically constant throughout, which is very gratifying, so that it does not exert any discernible environmental disturbance to the groundwater system of the Yarragaddy aquifer of the Perth metropolitan area, which has a salinity of about 250 ppm, which is practically fresh water. The very fact that the Groundswell heat pump operates in both heating and cooling is also very good to the groundwater system, because there's no, in a way, net extraction or heat or net dumping of heat in a sense, because in this case, we have a dumping of heat surely during the summer period into the groundwater system, which slowly diffuse to the sea. But here come winter, you see we are dumping colder water back into the same aquifer here, and that repeats in the following year as well. So in a sense, this hopefully reduce the environmental impact on our very precious groundwater asset. So in conclusion, the ground source heat pump system certainly performed a lot better compared with the air source heat pump in both the heating and cooling mode. The ground source heat pump has an average COP of 3.1, and that's for cooling, and then for heating, is COP is 3.9, which is very, very nice, because this certainly confirms that we have certainly tracked just a steady state data, because the difference between the cooling and heating is about 1, which is what the thermodynamics will dictate, which is very, very nice here. Now you can see that in cooling mode, the air source heat pump, in contrast, delivers 1.3 to 2.8 in terms of COP as against 3.1. And then for heating, the air source heat pump delivers 1.9 to 2.9 depending on the outdoor temperatures. So in conclusion, the ground source heat pump can be up to 100% more efficient than the air source heat pump in cooling mode, and 60% more efficient in heating mode. Now, in terms of the payback period, if as I mentioned right from at the start of this lecture, that because we are doubling up with the borehole irrigation, the payback period is very fast, and ranging from 0 to just no more than 4 years in payback, which is very, very nice. Yeah, very, very viable for a typical domestic application here in the Perth metropolitan area. So with that, I thank you very much for your attention, and certainly welcome your question, and I'm looking forward to interact with the audience. Thank you.
Thank you, Professor Chua. Please give the applause for the great presentation. Thank you, Professor. Now we are in the question and answer session. You can raise your hands or unmute your microphone to deliver your question directly. Anyone from the floor? Anyone? Okay, Arif Rahman Hakim, you can deliver directly your question, please.
Okay, thank you very much, Professor. It is a nice presentation, then give us a new perception about the system of the pump of the cooling and heating. So my question is, this study results was the application for our daily life need, like for the aircon or whatsoever. So what kind of implementation that we can use from the study? What we can improve in, like say, our icon or whatsoever?
Yes.
Your study, your research.
Yeah, this is a state government initiative because we are looking at how to gear ourselves up against climate change and to reduce overall emission. Yeah, because if we consume less electricity for the same heating or cooling capacity, it leads to a reduction in domestic scope 2 emission. Yeah. And also the other imperative is the commercial aspect of it, namely even to moms and dads, the domestic sector. Certainly this is a very significant capital outlay. You know, you've seen the drilling that took 14 days and the installation of the heat pump, but the heat pump itself, the capex of which is actually quite similar to the air source heat pump. So one of the major findings that we have arrived at is that if this were to double up with the borehole irrigation, which is quite commonly done in Perth, I'm not sure about Indonesia. That means we extract the groundwater for irrigating the lawn and the garden.
Yeah.
Quite commonly done here. Then we find that this scheme can rapidly pay back itself by no more than 4 years payback, and actually sometimes as fast as half a year, you know, because of the efficiency gain. Yeah. So because the owner have already decided, and this is a widely practiced thing. It's not as if we started off a demand, so to speak. So the owners have already decided to have a borehole irrigation, and current census, there are 190,000 existing borehole in the domestic sector already. So once we double, we piggyback on that one, the capex is really next to nothing, the additional capex. Yeah. And so they lead to very rapid payback and also mitigating against emissions, the scope 2 emission. And thirdly, from the state standpoint, the reason why I highlighted the summer and winter application is that from a state standpoint, because the energy is in the state jurisdiction, state government jurisdiction. So it is hoping to make use of ground source heat pump as a means to slash the peak load in both summer and winter.
Okay, so get the point. Yeah, okay, so the benefit of this study, yeah.
Yeah.
So now it is being implemented, or just still now this is the grand concept only, they're still in the concept, or you already starting to implement this in the Australia?
Okay, broadly speaking, geothermal energy, I mean, of course, Indonesia is leading its way as the second largest, the leaders in geothermal power. So I should give my due respect and acknowledgement of that, first thing first. But in Australia, it is certainly heating up. It's not, certainly people are gaining more and more interest. Right now in WA, most of these ground source heat pump projects are installed by wealthy individuals who want to incorporate more environmental friendly kind of technologies, to their property. And so these are the visionary uptaker of the technology. But significantly in Sydney, there is a 800 units project being taken out and supported by the Federal Arena grant. So this is in Sydney, and these are big property development, and there are 800 units being deployed there. Oh, good. Okay. Okay. Thank you very much, Professor, for your explanation. You're most welcome. Yeah. Thank you. Thank you.
Thank you, Professor. Next, this question, Mia Miranda, you can deliver directly. Okay, Professor, ground source heat pump only suitable for the new building, doesn't it? That's the question from Mia Miranda.
For new building, namely greenfield projects, certainly yes. Okay, certainly yes, because it's a lot more convenient. But for those that actually has the borehole irrigation in developed suburbs, actually it's quite common practice for the driller to come and drill the borehole actually. And so it is not inconceivable that this can also be deployed in developed suburbs as well. In fact, there was a time when I was thinking of engaging a driller to come to my property to drill for the borehole irrigation, but eventually I just decided that to stick to just tap water irrigation. But that goes to show that this is entirely possible. Yeah. And I'm in a very well-developed suburb, for example, and so this is not a showstopper, put it this way. Yeah.
So it can be developed without the irrigation system?
It can be, but of course, in which case one has to fork out the initial capex, yeah, and many kind of environmentally conscious dwellers, they do that, yeah. Although I would advise members of the public to combine that with borehole irrigation, which is a very common practice, yeah.
Okay, thank you very much, Professor.
Thank you.
You can raise your hand. I see one participant raise the hand. Okay, please unmute your speaker, your microphone.
Okay.
Okay, thank you. Please.
Okay. Thank you, Professor Tong. Yeah.
You're most welcome.
Yeah. If we compare that GSP system with HSP ground system with air system, which better for energy saving, saving energy?
It's certainly the GSHP because of you can see on this slide, for cooling, this is 1.3 versus 3.1. This 2.8 is when it is very near 25, 26 outdoor air temperature, by the way. Yeah. So it's at times when it's not needed. Okay. So you can see, yes, when the outdoor air is warm, yeah, it can get close, but that misses the point. It is when the outdoor is cold, then we require that. So it can be up to 100%. I wouldn't say it's a 300% because this is a pretty cold temperature. So typically it's can be up to 100% more efficient for the ground source heat pump or GSHP system in the cooling mode. Now in the heating, you can see here, the ground source heat pump or GSHP remains at a very high COP of 3.9 compared from 1.9 to 2.9. Again, you can see here, this 2.9, well, why is it needed? Again, this 2.9 is when the outdoor air is pretty warm. Again, yeah, when we do not need heating. Okay, yeah. So, and that's only then it comes closer to the ground source heat pump. But typically, it is a lot lower, like can be as low as 1.9 versus 3.9. So overall, we are saying on a whole, and not going to the extreme, it can be 60% more efficient than an ASHP system. I hope that answers your question.
Okay, thank you, Prof.
You're welcome.
Next, so we come to another question, Professor. As this experiment is performed in Australia, in Western Australia, and on the basis of its result, is this COP is achievable in different countries, such as in South Asia, Indonesia, Malaysia? How is your opinion, Professor?
No, of course, I actually grew up in Malaysia, by the way. So when you mention Malaysia, it's close to my heart, Kiki.
Me too, Professor.
So
I'm from. Yeah, Professor.
Yeah,
Continue,
sorry.
Professor.
Yeah, sure. So over there, and I do know that when I grew up as a boy, there are many wells in Malaysia. Yeah, I certainly remember those cool water. Now, I will say that certainly I will expect similar efficiency gain for cooling. Obviously, I don't think heating is ever needed in Southeast Asia. I'm not too sure about Indonesia, but certainly not for Malaysia. So in that regard, yes, I will expect similar efficiency gain, because the air in Malaysia, I do know, is hot and humid. I know that very well, although I don't mind the heat because I grew up there, and I find it very agreeable, by the way. So certainly the air in cooling, yes, but there's a caveat which I need to highlight, is that in WA we have very strict groundwater control. Namely, we do not allow for a net extraction of groundwater. All right. So, for example, if it's not meant for borehole irrigation, every single drop of groundwater that we extract and pump up must be 100% returned underground. Not a single drop can be discarded into the surroundings, yeah, or pump up or for consumption, okay? Because otherwise it will lead to a rapid drop in the water table. The only exception is with borehole irrigation, because that is limited to in Perth 3 days a week. And in this particular study, the EPA regulations, we are allowed to do subsurface irrigation, just to also test out this concept, namely the groundwater is not sprayed into the air as most of the householder will do in Perth. Well, for example, my sprinkler in my garden is sprayed into the air, by the way, and then drop onto the garden bed, right? So in this case, it's not. It is drip feed into the subsurface underneath the lawn, at the root system of the lawn, okay, that you saw in the picture of the property. So these are the caveats I would say that we need to watch out for. Otherwise, the water table will drop rapidly.
Nice explanation, Professor. Maybe this is also answered Rizalmanto funny question. This GSHP can be used in the tropics country like Indonesia.
Absolutely for cooling application especially, but with my caveat about not extracting the groundwater. Otherwise, Indonesia will be liable for that, because now you suffer from a rapid or significant drop in the water table, which is certainly not something that I would like to see. Yeah.
Yeah, Professor. Regarding that question, Professor, like your statement, Indonesia also have huge potential unexploited geothermal energy. 8.9% only have utilized. So in your opinion, what is the main obstacle in developing geothermal energy, especially especially for domestic application?
Yeah, well, certainly I'm not curious about the Indonesian context. I personally have never been to Indonesia, yeah, so I couldn't say too much there.
Maybe you can come to Indonesia, Professor.
Thank you very much, and I certainly hope so too. Yeah, COVID permitting. Yeah, and I've had my full 2 jabs, by the way, of AstraZeneca.
AstraZeneca.
Yeah, but looking at the, I mean, reflecting on the Australian situation and the Australian lesson learned to date is that the whole issue is, first of all, of course, the general awareness of the geothermal energy is become more aware as people have become more environmentally conscious. Yeah, and secondly is the need, of course, to be rational about the capex outlay, which can be substantial, and which is why, as part of a study, we actually dug down a lot into what will actually make these a more viable option for the general population, not the rich people, yeah, or not the visionary people. Yeah, they may be very environmentally conscious. I certainly applaud that, but you know, it remains a very rich game. Yeah, but so when we double down, we concluded that if this were to combine with things that people usually will do in Australia is borehole irrigation, then it becomes very, very commercially viable, even in the domestic sector. Okay.
Nice, Professor. Another question from the floor. Another question? Okay, I will read the question from the column chat. Are the ground source and also the air source is a noisy when is it on operate?
Yeah, that is a fantastic question, and I thank the person who raised this question. This was actually studied in our project, but out of ethical reason, we cannot kind of like openly publish the result. But cut to the chase, the ground source heat pump is very, very quiet.
Oh, see.
Okay, and this obviously in Perth is obviously very, very beneficial because we have very quiet suburb here. There's very little noise because I came from Malaysia and Singapore. When I first came to Perth, it was pin drop quiet, you know, in the evening, you know, very, very calm. And so you can see the kind of noise that can disturb the neighborhood. Now, air source heat pump, I will not go into this in the project because it's a bit, I shouldn't. But air source heat pump, it is very widely known that it is quite noisy, okay? And I mean the outdoor unit. And there are actually in Perth or WA in general, there are strict legislation as to the decibel that is allowed over a certain period of time. And as a matter of a general knowledge in the trade is that most of the time, the noise level exceeds the environmental regulation for air source heat pump. But that is another very important benefit of ground source heat pump in a suburban application. Yeah, I thank the audience for this question.
Okay, thank you very much, Professor. No wonder you win the prize.
Oh, thank you.
Research. Another question from the floor. Is there any question from the floor? If not, I will read the question during the presentation that were sent to us. There are some. Is there some treatment for the groundwater prior to utilize the energy?
No. The simple answer is no. We simply need a filter, just because we have because the water here is quite iron particulate rich. So we actually have put in a filter. The supplier, I mean, put in a filter to filter off those iron-rich particles. But actually, at the end, they actually removed that. To be honest, we were quite concerned about that. But apparently, over the course of study, it did not pose any problem. In fact, the filter did for a while stop the operation of ground source heat pump, because I think the owner forget to clean the filter. Yeah, because the filter clogged up. Yeah. So, but otherwise, there is no need to pre-treat the water. The water is very fresh, 250 ppm in terms of salinity. It's practically fresh water. We are quite spoiled here and are very well endowed by very treasured asset. Yeah.
How about the treatment for the system, Professor? Maybe some part of the machine or the system should be changed or replaced
No.
to keep it's working.
No.
No, it's great.
Yeah.
Okay.
No. Pretty sweet. Yeah. But perhaps the only thing I should add here is during the drilling phase. Yeah. And this is well known here in WA, because we have feral-loving bacteria thriving in the soil. And so during the drilling phase, the drill bits got to be remain in an antiseptic condition. Okay, so it has got to be yeah.
Please,
So
please mute your speaker, your microphone. Okay, continue, Professor.
Yeah, sure. So it is some painful lesson has actually been learned in the industry, that if this is not done in a fastidious manner, then it will allow the bacterial colony to form and take root, and then after which there will be the trouble in re-injecting the groundwater back underground. So yeah, this part is pretty important, but only during the drilling phase. That the drill bits, when it get into contact with the mud, surely, yeah, when it come out, got to be washed and wash in antiseptic solution to make sure it is all free of bacteria before further drilling. Okay, this is a pretty well understood practice in the industry here. Yeah, that has to be very carefully observed, the antiseptic condition.
So that the treatment you should put the inhibitor for control the
no, it is not. No, it's not. It's just antiseptic solution to make sure
just
there's no
solution.
bacteria. Yeah. There's no ongoing inhibitor needed. No.
Oh, no need inhibitor.
No. As you can see, it's all plastic system. PVC part. That's about.
Yeah, good, Professor. Another question, please. Another question. Okay, if not, I will read another question from the audience. Actually, there are two kinds of the heat pump, isn't it, Professor? Mechanical and a chemical heat pump.
Yes, there are heat-driven heat pump, but is not very rarely adopted in Australia. Although, having said that, I want to point to a tri-generation system in the Qantas headquarters. I can't remember, but certainly in the eastern state, whereby they make use of a heat-driven absorption chiller to make use of the combustion waste heat forgot to generate power as well. To deliver cooling, so to giving rise to a very high energy efficiency. Yeah.
Okay, Professor. maybe this a question is not about your research now, your topic, but it's still in your core in the geothermal energy research. Would you mind to answer the question, Professor?
I'll try my best. Yeah.
Commonly, geothermal energy is from volcano. How Australia could develop this renewable energy since Australia has no volcanic structures?
Oh, I see. Okay, sure. I can answer that. Yes. I suppose this question pertains not for this air conditioning application, but toward power generation, right? Yeah. Yes. In fact, earlier this afternoon, I was in conversation with my colleagues within the company, Good Water Energy, and we are certainly kind of developing this technology in WA and in Northern Territory. To answer now to your question, then how exactly do we do that? Do we do that? Because we obviously do not have a volcano. In fact, our land mass here is so ancient that it hardly contains any sulfur, by the way, because it's such an ancient land mass. But instead of doing that, we are going to drill deep. Certainly not the kind of depth accustomed to in Indonesia, like no more than 3 kilometers, I'm pretty sure. But we will go down to 7-8 kilometers here. Okay, so that we gain not steam. Unlike Indonesia, we are not going to get steam here. Instead, we are going to gain high temperature water, say on the order of close to ballpark 300 degrees C water. We're going to pump them up above ground and harness the enthalpy of the hot water to deliver electricity and distilled water before returning the spent water down underground. I hope that answers your question.
Okay, thank you very much, Professor. Maybe the last question from the floor and the last question for this symposium. Please, anyone? Okay, it's time return to me again. How much the cost for the house with this system compared to the system without the system, Professor?
Sorry, you mean compared with the air source heat pump or what is it?
With the system, with the piping system in the ground compared to the without the system. Is there any how much the cost is the comparison?
So it is literally the underground cost is literally the same as the above ground cost, 50-50.
Oh, 50-50. That's good. Yeah. Okay, Professor. Thank you for the answering those questions and for the great presentation.
Oh, you're most welcome.
Your article will be published in the next issue of the Teknomekanik journal. You can access our journal as stated in the flyer and the poster. So keep up our poster and flyer and share to your friends to access the other article in our journal.
Thank you.
Okay, Professor, and don't forget to subscribe our YouTube channel as stated in the chat column and also in the flyer.
Sure.
Share to your friends in your university.
Okay.
It is our happiness to have you here, Professor.
Thank you, Kiki.
Okay, Professor. Would you mind being our international board advisory in our journal, Professor?
Excuse me?
Would you mind being our international board advisory in our journal, in the Teknomekanik journal?
Sure. I'm very much honored. Yeah. Thank you.
Okay. We will send the invitation letter and appointment letter for you soon to your email.
Sure, I'll look out for that.
Another, we wish that we have a collaboration between Universitas Negeri Padang and your university, such as research collaboration, student exchange, PhD program for our lecturer, visiting lecturer. Is it possible for us, the professor?
Absolutely, and you should ask Tina whether she's
Okay.
happy here in Perth. Yeah.
Tina, I love you so much. Okay, finally, Professor, it's our happiness to have you here with us, Professor. We would like to thank to you for your contribution in our event and journal. Here is your certificate as stated in the monitor, and it will be sent to you soon, maybe through the Tina. Wish you all the best and many success into your life, Professor, and all of the audiences. We also would like to appreciate all audiences for your active participation in this event. Professor and the audience, we apologize if there is any lacking in our event. Hopefully, this symposium will be beneficial for everyone. For the audiences, your certificate will be sent to your email that you have listed in the registration link. Finally, it is the end of our symposium. Thank you. Thank you all and see you in the next symposium. Don't forget to follow our YouTube channel to know about next our symposium maybe end of this October. And the fourth symposium will be held in the early December in this year. Thank you for you all. Thank you, Professor. Thank you, Tina, for your contribution.
Thank you, everybody.
Bye-bye, Professor.
Bye.
See you all in the next symposium. Wassalamualaikum warahmatullahi wabarakatuh.